Alrighty, good morning. Happy Wednesday. We're going to learn our last new lesson today before the quiz, which is on Friday. So you will spend tomorrow reviewing and then the first half on Friday also reviewing. Okay, so we're going to add on some more identities today. These are the sum and difference identities. If we take a look at the first example, it just wants to do a little discovery, do the two equal each other. So if we do some work off to the side, so pi over 3 plus pi over 6, that's going to be 2 pi over 6 plus pi over 6, which is just pi over 2. So cosine of pi over 2 equals 0. Okay, so now what if we separate those? Cosine of pi over 3 is going to be 1/2 plus root 3 over 2. Okay, if we put that together, that's 1 plus root 3 over 2. Are these two equal to each other? The answer would be no. All right, let's take a look at another discovery example. So let's say we subtract them this time. So we have 2 pi over 6 minus pi over 6, which just equals pi over 6. So let's take the cosine of that, and that gets me root 3 over 2. Okay. If we separate the angles, we would get 1/2 minus root 3 over 2. And if we combine that, 1 minus root 3 over 2. So once again, do these two equal each other? Hopefully you said no. Okay, so just taking the two angles and splitting them they're not equivalent to each other. So we need to put in some identities so that they do equal. Okay. So after the lesson, make sure that you guys write these identities in the back of your notes, which has all the identities on it. So the first one is cosine of theta plus b. Okay, we know that that's not equivalent to cosine theta plus cosine beta. So instead, it's going to be cosine theta, cosine beta, minus sine theta, sine beta. Okay, notice that it's the opposite sign for cosine. So here's a plus, there's a minus. Okay, and then cosine of theta minus beta looks exactly the same, besides the fact that it's going to be plus now, because the sum and difference identities for cosine, the signs are opposite. Okay. So these are two new identities that you guys need to memorize and then also write on your identity sheet. All right, so let's just make sure that these identities actually work, okay? Especially in the beginning, I think it's important to write out the entire identity so that way you learn it. So we have cosine of pi over 3 and then cosine pi over 6. And then it's the opposite sign in the cosine identities. And then we take sine of those same exact angles. So cosine of pi over 3 is just going to be 1/2. And then cosine of pi over 6 is root 3 over 2. Minus sine of pi over 3, sine of pi over 6. So this gives me root 3 over 4 minus root 3 over 4, which just equals 0. If you go back up to the top, that is what we got up here. Okay, we got it equal to 0. All right, and then let's apply the identity down here. So cosine pi over 3, cosine pi over 6, plus sine pi over 3 sine pi over 6. Okay, we already found the identities up top. So 1/2 times root 3 over 2 plus root 3 over 2 plus 1/2. So that gives me root 3 over 4 plus root 3 over 4, which is 2 root 3 over 4, which equals root 3 over 2. If you go back up to the top, once again, those equal to each other. So now some of you might be asking, why are we doing all this work when we could have just done pi over 3 minus pi over 6 like we did up top and found the coordinates? Great question. This is just to prove our identities. Okay, what happens when an angle is not on the unit circle? That's when we're going to use these identities with angles that are on the unit circle to evaluate. Okay, so once again, this was just for learning purposes. We're going to use these identities a little bit differently later on. All right, so let's add on to our identities. So sine of theta plus beta, it's a little bit different. I think this one's a little bit tougher to memorize. So you first take the sine of theta, but then you take the cosine of beta. Sine's the same sign, and then you take sine of beta, cosine of theta. Now, some books might write this like the following. So what they do is they keep the angles in the same order, so theta always comes first and then beta always comes second. This is equivalent, right? 2 times 4 is the same thing as 4 times 2. So just to let you know, if you happen to look it up or you work with a teacher or student somewhere else, these are equivalent to each other. All right, so then let's apply this for subtraction. So sine theta cosine beta minus sine beta cosine theta. Okay. So once again, you guys are going to apply these rules to your identity sheet on the back. All right, and then we still have to do tangent. So the sum and difference identity for tangent goes tangent theta plus tangent beta divided by 1 minus tangent theta tangent beta. Okay, if your brains feel like they're getting overloaded right now, they probably are. All right, you got to practice these note cards. I know Riley likes to write them out. Okay, whatever it's going to take for you guys to memorize them. Once you memorize them, it goes a lot faster and it doesn't seem as overwhelming. So for the difference, it's tangent theta minus tangent beta all over 1 plus tangent theta tangent beta. So notice for this identity, same sign in the numerator, opposite sign in the denominator. Once again, same sign, opposite sign. Okay, sign, the signs are the same. Okay, see how the signs are the same? And then for cosine, they were opposite of each other. All right, so let's go ahead and try some examples. So here, we're going to work backwards, okay? So yes, pi over 6 is on the unit circle, but pi over 12 is not. So this is an example of where we would use the sum and difference identities. And we're going to work backwards to get one angle. So first of all, you have to decide what sum and difference identity we are using. Well, if you see 2 cosines in the front, then that means that this is going to be the cosine. So cosine of 2 angles. Okay. Then look at the inside. This is the subtraction sign. And remember that cosine's the opposite. So we put a plus. Okay. And then we just have the 2 angles. So pi over 6, pi over 12. Okay, let's do some work off to the side so that we can get a common denominator to add these 2 fractions together. And we get 3 pi over 12, which is the same thing as pi over 4. So now we're going to take cosine of pi over 4, and that gives me root 2 over 2. So root 2 over 2 is my final answer. Okay? Once again, this was not, pi over 12 is not on the unit circle, so I couldn't just apply, just go through and find the coordinates. Instead, I had to figure out what sum and difference identity I was starting with. In this case, it was cosine. There was a subtraction sign in the middle, and cosine's the opposite, so we change it to addition. Then we add the two angles together, then we evaluate that angle, and we got root 2 over 2. Okay. All right, let's do another example. So hopefully you recognize that right away this is going to be a tangent sum and difference identity. Okay. And then you have to check the top. So the numerator, the sign is always going to match. So this sign is going to be subtraction. Okay. And then we're going to subtract the two given angles. Notice that neither one of these angles is on the unit circle. Okay, then let's do some work over to the side, because remember that you're not going to have a calculator. So we get 32 pi minus 5 pi over 36. That's 27 pi over 36. Reduce our fractions, and that becomes 3 pi over 4. So remember that that's not your answer. You still need to take the tangent of 3 pi over 4, which is just going to be -1 because we're in quadrant 2. Okay, so once again, this is going to be the tangent. Then you look up on top, whatever this sign is, that's going to be the sign in here. Then you take the two angles and just plug them in, subtract the two angles, get 3 pi over 4, and then actually take the tangent of 3 pi over 4, and you get -1. Okay. All right, let's go to the next page. Okay, so here's where we are going to expand out. Now this time we're going to be given an angle that's not on the unit circle, and we have to figure out which two angles would add or subtract to that number so that we can apply the identity. So I think it's probably the best option is to first change this into degrees. Okay, and you're going to get 15. A little helpful hint here, 180 divided by 12 is going to be 15. Okay, we actually use that number a lot, so just FYI. All right, so now we need to come up with two angles that are on the unit circle that either add or subtract to 15. Okay, now there's several different options you can use. I'm just going to use 45 minus 30. That gives me 15. So I'm going to do cosine of pi over 4, cosine of pi over 6. Okay, if you use the angle degree measures, it's fine. I just want to make sure that we continue to work in the unit circle in radians. Since we did subtraction here, we're going to have to do addition when we use the identity. And then we have sine of pi over 4, sine of pi over 6. Okay. And then just go through and evaluate that. So this is going to be root 2 over 2 times root 3 over 2 plus root 2 over 2 times 1/2. So we get root 6 over 4 plus root 2 over 4. Root 6 and root 2 cannot be combined. They're not like terms. So my final answer is root 6 plus root 2 all over 4. Okay. Now it's possible if you used different angles, okay, it might look a little different, but the final answer should be the same. Okay. So once again, find the two angles that add or subtract up to that number, and then just apply the identity. So sine of 5 pi over 12. So the first thing we're going to do is rewrite this in degrees. So 180 divided by 12 is 15. 15 times 5 is 75 degrees. So two angles that add or subtract up to 75. I'm just going to use 45 and 30. Okay, remember that you want to use angles that are actually on the unit circle, otherwise how are you going to evaluate them? So this is going to be sine of 45 plus 30. So let's write out the identity. Sine 45 cosine 30. Remember that sine's the same sign. And then sine of 30 cosine of 45. Okay, so we get root 2 over 2 times root 3 over 2 plus 1/2 times root 2 over 2. So root 6 over 4 plus root 2 over 4. Rewrite it as 1 fraction. Okay. Now some of you might notice that we just got the same angle or the same coordinates as we should have, because of the fact that this was cosine of 15 degrees and this was sine of 75 degrees. They were co-function identities. So bringing back day 1. Remember that day 1 is 90 or pi over 2 minus theta. So 90 minus 15 gives me 75. So cosine and sine of those two should be equal to each other. All right. Next type of examples that you guys are going to see. You're going to be given ratios of triangles, okay? Make sure you guys know your Pythagorean triples. That'll help you out so much, okay? We have to find x, y, and r, and then we apply the identities. So what I like to do when I'm working with these problems is do the work off to the side. So A is in quadrant 2, so that means my signs are negative, positive. We have y, x, and r. And then B is in quadrant 3, so both signs are negative, y, x, and r. Okay, so let's go back to the information we were given. So cosine of A is negative 8 over 17, so negative 8 and then 17. Okay, to find y, remember that's Pythagorean triple, so this is just going to be 15. Pay attention to the sign. So it's positive, so this means this is a positive 15. Okay. In the other example, sine is negative 5 and r is 13. Okay, once again, this is a Pythagorean triple, 5, 12, and 13. So I'm going to write down 12, but then we have to check the sign. Okay, go back up top. And x needs to be a negative because we're in quadrant 3. I can't tell you how many times students make a mistake on this part right here. Okay, pay attention to the signs of which quadrant you're working in. Okay, so since we are in quadrant 3, x had to be negative. All right, and now we're going to apply the identity. So cosine A, cosine B. And then cosine's opposite, so sine A, sine B. And now we're just going to go over to the right and plug everything in. So cosine of A is going to be x over r, so negative 8 over 17. Cosine of B is going to be negative 12 over 13. Minus sine of A, which is 15 over 17, and sine of B is negative 5 over 13. Okay. Now I know this is going to be hard for some of us to do this without our calculators. The questions on the quizzes and tests, the Pythagorean triples are very basic, so like 3, 4, 5, 7, 24, 25, which give you really nice numbers. Okay. Biggest thing is make sure that you pay attention to the negatives. So negative times a negative is a positive, so this is 96 over 221. And then you had a negative and a negative here, so that's going to change this to addition. And we're going to get 75 over 221. Add those two together, and we get 171 over 221. Okay, so like I said, I know some of us this might be hard without a calculator, but just know that the numbers are a lot nicer on quizzes and tests and the DBA. Okay, so we're going to do the same thing, but now we're going to do this for the sign difference identity. And we need to make sure that we write this out correctly. So sine of B and then cosine of A. Remember that the signs are the same. And then we're just going to use the information up top again. So sine of A is 15 over 17. Cosine of B is negative 12 over 13. Minus sine of B, which is negative 5 over 13. And cosine of A, which is negative 8 over 17. Okay? So make sure, please, that you pay attention to negatives, which actually, looking at my answer key, I did not. All right, so this first one should be negative 180 over 221. And then you have 3 negatives here, so then this is going to stay subtraction. Minus 40 over 221. So I get negative 220 over 221 for my answer. Okay, so make sure that you pay attention to negatives, especially if you're not using a calculator. All right, last example for this page. Make sure you notice the order. Now with addition, it won't really matter, but for subtraction it would. So tangent B plus tangent A all over 1 minus tangent B tangent A. Okay, so tangent's the toughest one for us in the terms of making sure that our arithmetic is correct. So tangent of B is negative 5 over negative 12, which is just 5/12. Plus tangent A is going to be a negative 15 over 8. And then in the denominator, it's 1 minus those two numbers. Okay. All right, so let's do some side work here. Let's get a common denominator. So 10 over 24 minus 45 over 24 will give me negative 35 over 24. Okay, and then let's do some work here. So this is going to be 1 plus 75 over 96. All right, so common denominator on this, so 96 plus 75 over 96 is going to be 171 over 96, which simplifies to 57 over 32. Okay, then once we get there, you can multiply by the reciprocal, and we should get negative 140 over 171. Okay, once again, I know these numbers are big and they're tough. These numbers won't be as difficult on the quiz and the test. Okay. All right, last page we have to talk about is verification. So remember, with verification, we're working with the left side of the equation, and today we're going to use the sum and difference identities. So for like example number 1, I know this is a co-function identity, but we're going to use sum and different identities to expand this out. So apply the identity, same sign, okay, and then just evaluate. So sine of pi over 2 is 1 cosine theta minus sine theta times 0. So that's just 0 this side. So that gives me cosine theta, which equals the right-hand side. Okay, so just leave theta as theta. So like cosine theta is cosine theta. Sometimes students will drop the cosine for some reason. Okay, so if you can't evaluate the angle, it's not a numerical number that you see, just leave it as is. So sine of theta, cosine theta is cosine theta. All right, let's take a look at number 2. Number 2, we're going to have a little bit of work on this problem because we got to use the identities twice here. So we have cosine of pi over 6, cosine theta, opposite sign, sine of pi over 6, sine of theta, plus sine of pi over 3 cosine theta, plus sine of theta cosine of pi over 3. Okay, so once again, all I did was apply the identity. So this is the cosine addition identity. This is the sine addition identity. So cosine of pi over 6 is just root 3 over 2 times cosine theta. Remember that we leave cosine theta as is, minus sine of pi over 6, which is negative 1/2, times sine of theta, plus root 3 over 2 cosine theta, plus 1/2 sine of theta. So now notice that these cancel out, and you're left with root 3 over 2 cosine plus root 3 over 2 cosine, which is 2 root 3 over 2 cosine theta. The 2's cancel out, and you're left with root 3 cosine theta, which is exactly what the right-hand side states. Okay, so that is it for today. Like I said, this was the last new material before your quiz. So please, please, please start memorizing those identities. Tomorrow we will, if we can, we'll try to FaceTime if you guys have any questions. But hopefully, as always, you guys are working well together and helping each other out, because I know some of us will pick this up a little bit quicker, just because of memorization and applying the identities. But email me if you guys have any questions. I'll try to answer them if I can through email. But other than that, I hope you have a wonderful day, and see you soon.